Name the actors in the movie The Top Gun.
Val Kilmer, Meg Ryan, Tom Skerritt, Kelly McGillis, Tom Cruise and Anthony Edwards.
The demo that you've just seen is an extension of my previous video, where in this video I'll show you how you can create your own virtual assistant. So if the algorithm brings you to this video first, then I'll attach a link to my previous video. You can go through that and then come back and watch this particular video. So everything will start making a lot of sense. Okay. In my previous video, what I've done is I've used the normal CPU version of a Google Colab session. In this video, I intend to transcribe the audio and read out the text that is generated from the audio file, which is where I require the Whisper model that will help me transcribe text. Okay, so which is where what I require in this particular activity is a GPU. I'm using a Google Colab session. If you're kind of replicating this locally, then it's good to have a GPU handy. But if you're doing it on cloud, the way I'm doing it, then it's good to select T4 GPU because the Whisper processing will take a good amount of time. So I require a GPU and I click on save. The other thing that I want to mention is that I have my PaLM secret key in form of a JSON file already up and running in my Google Colab session. So you too can create a JSON file with the API and upload it the way I have uploaded. Okay. So now that the entire background piece is up and running, what I'll do is I'll quickly carry out the installation process. So I'll install the dependencies that are required. So here is the message that you must restart the runtime in order to use the newly installed software. So once the entire installation happens, I'll quickly restart the runtime. Now that the installation is done, I'll quickly go forward and restart this particular runtime. So I'll go to runtime. I'll click on restart runtime. I'll click on yes. There are a lot of unwanted outputs that I see on the screen. So I'll clear all outputs and I have everything set up now. So I'll quickly go forward and I'll make the imports happen. I'll load the JSON file in the data variable, and from data I'll kind of reference the API key and use it into the palm.configure function. So that is something that I'll set up. So this function is basically the function that I've kind of borrowed from my previous video, wherein the entire function is generated using Google MakerSuite. So the rocket science here that goes behind the scene is how well can you define the prompt, and all the prompting that you've done would appear into this particular variable called as prompt. And later, in order to use the PaLM model, you call the generate_text function by passing in the prompt and you get the response. Okay. Finally, you return the response.result and you have the response ready in hand. Okay. So this is something that we've already talked about in the previous video. So I wouldn't go into depth of the entire function. So I'll quickly import this into memory. Neo4j will return multiple results, which is where if I have to combine it and format it so that it looks more readable and presentable, I use this particular function, which is format_names_with_ampersand. So what this does is, if the list has more than 3 elements, the first 2 elements would be combined together with a comma separated between them, and the final will have an and. So if there are 3 names like Sachin, Virat and Saurav, so the output will be Sachin, Virat and Saurav. So that's how the entire formatting is. So I input a list and I get a string back. Okay, so this is what this particular function does. I've already talked about this particular function, which helps me query and return the key. So there are aspects of the response that I need to format. Some places there are /ns which I want to remove, which is where the first regular expression comes in handy. The second expression comes in handy to extract the values after the return statement, which acts as a key while I'm extracting the response. So these are the 2 regular expressions that I require handy. And all of this works on the query that is generated from the Google PaLM 2 model. So I've created a function for this as well, and I've talked in depth in my previous video. So I'll quickly import this. So this particular function is where I connect to the Neo4j database using the Python drivers, and whatever results I get, I kind of append it into this particular list called as out_list. And finally, once I have the output ready in form of list, I pass that list to this particular function, which is format_names_with_ampersand. and I get the result that I desire, that is like a formatted result that I'm kind of chasing for. So I kind of go forward and import this particular cell as well. Finally, in this particular function, what I do is I generate and execute a cipher query based on the input query that is generated by the PaLM2 model. So all of this will kind of fall into place one after the other. So I'll quickly import this particular cell as well. So here is where the new magic comes in. So here I have a function called as transcribe. I pass in the audio. This is the input audio. So whatever I speak, I'll kind of record that and I'll save that in form of an audio. Now what I do next is I kind of initialize the language for the speech to text conversion, which in our case will be English. I've defined two variables which are currently blank strings. If the function finds an audio, then using the whisper model that I'll kind of load going forward, I load the audio. I'll pad or trim the audio based on the input that I receive. Once I've done that, what I'll do is I'll pass the audio to the function called as log mel spectrogram. So the audio file, which is basically a file which contains amplitudes of the signal, this particular function will convert those signals into frequencies, which is where log mel spectrogram comes into picture. Now once I've done that, using that spectrogram that is generated, the model will try to detect the language of the audio. Then there are multiple decoding steps that follow after that. And finally, once the decoding result is ready, it will be saved into the variable result underscore text. If there is result underscore text that is generated, then this particular result underscore text is the input to my entire Cipher module slash Google PaLM API module. So this particular variable that you see here will have nothing else but the actual query that you ask. So for example, if I want to know the year of release of the movie The Matrix, so this is the transcribed text which will pass as an input to this particular function, which is generate and execute cipher query. This in turn will be converted to a cipher query by the PaLM2 API. Once I have the cipher query, the entire execution will happen on the Neo4j database that is up and running. Once the execution happens and once I get the result, I'll kind of trim the result, modify it, or I'll kind of format the result. And once the formatted result is ready, up and running with me, once I have the result handy, I'll kind of pass that to the Google text to speech module, which will generate speech from the text that I pass. So all of this is what I kind of create here. And finally, I return the three values just to be sure of what each module is returning. So I return the result text, which is the transcribed text that is generated. I return the out result, which is the final result that is generated by the Neo4j query. And finally, this is the file name, that is the temporary MP3 file that I want to create after every run. Okay. So if this idea is clear, I'll quickly move forward. In order to transcribe the audio that is generated by the input, I first have to load the base model of Whisper and save it into a variable called as model, which is what I've done using this piece of code. Just to be sure if my model is running on a GPU, I'll call the command model.device to check if it's a GPU or not. So it says the type is CUDA, that means I'm running on a GPU, which is great. Using this ffmpeg command that you see on the screen right now, I basically create a temporary empty MP3 file which will keep replacing after every run. So this is the command that I'm using to create a temporary MP3 file. So I'll run the cell. So here is the output. So just to show you that after this particular command, we have a temp.mp3 file that has been generated. So I'll close this window. Here is where now I connect to Neo4j using my credentials, username and password. So I'll quickly run this. Finally, what I do next is I create a Gradio interface. So the entire chatbot that you will see right now will be powered using the amazing open source library called as Gradio. So I define three sets of outputs. First output is the speech to text output, which is pure text. The second output is the final query that is generated firstly by Google PaLM2 model, which is then passed to a Neo4j driver, and you kind of execute the query on Neo4j, get the results, and the final output that is generated is saved into a variable output2. Finally, the output that is generated in the previous step is converted into audio, which is where output 3 comes in. The input is basically a microphone input, which is what I've defined here. And finally, everything is up and running. So I'll quickly run this cell to launch the interface. I'll quickly run this so that I have a bigger interface to play around with. Let me ask my first question. Who directed the movie The Matrix? So here is where the execution is happening now. So here is the output. The output is who directed the movie Matrix. So this is the speech to text output. This is the PaLM 2 plus Neo4j execution output, which I'm assuming is correct. And here is the output using audio.
Lana Wachowski and Lily Wachowski.
I'll ask my next question now. Name the actors of the movie When Harry Met Sally.
Carrie Fisher, Billy Crystal, Bruno Kirby, and Meg Ryan.
So this is the speech to text output. This is the output that I generate from the query. I'm totally mesmerized in terms of how the solution is shaped up. If you look at the entire workflow, right, I'm asking a question to my database, which is a Neo4j database in pure natural language and in pure voice. I'm not inputting any text. The text conversion is happening automatically using Whisper. The output that is generated is then passed through the Google PaLM 2 model, which is converted to a Cypher query. The Cypher query then runs and generates the final output by querying the Neo4j database. Once all of this falls into place, I get an output here. I am truly mesmerized. Well, this is all that I had in today's video. I hope you found this informative. If you really like the content that I'm creating on large language models, it would be super motivating if you can press the subscribe button and also press the bell icon to be notified for amazing videos that I plan to create in the future. Thank you so much for watching the video.